People, it's time to start balancing equations. I know you're afraid. It's going to be okay. Seriously though, balancing equations is one of the three big, nasty topics in chemistry. This is one that'll make grown adults cry. But you know, it's really not that bad if you know a couple of good tricks, and I'm going to teach you those tricks. So, what is balancing? We're not talking about like a circus act here. We're talking about the law of conservation of mass. So, for example, if you're in my class, you've seen this reaction in class where we take some magnesium metal, we put it into oxygen in the air, give it a good spark, that starts the reaction, and it creates this white stuff called magnesium oxide. Problem is, chemical reactions, they don't create new atoms. They don't destroy atoms either. But the way I've written this equation kind of suggests that chemical reactions do that, right? You see, the way I've written this, we have one magnesium atom to begin with, and in the end we still have one, so that's actually okay. But to begin with, we have two oxygen atoms, and somehow now after the reaction, we only have one oxygen atom left. And that can't happen, right? All that chemical reactions do is they rearrange the atoms to make new molecules and new formulas. They don't make atoms disappear, and they don't make atoms appear out of nothing. So really, this equation, as I wrote it, it's a lie. It's a straight-faced lie. It doesn't really happen this way, because what I've written here suggests that an atom is destroyed. So what we need to do is called balancing, okay? In truth, what really happens is, if I start with two oxygen atoms, I'm going to end with two oxygen atoms. So that's why I just wrote this 2 here. And this now says that I ended with two magnesium atoms, so that means I must have started with two magnesium atoms to begin with. And this is the full balanced equation for that chemical reaction. Okay, so what really happens is one oxygen molecule comes and reacts with two magnesium atoms. And all of those 4 atoms together make 2 formula units of magnesium oxide. Okay, so what I just did is I picked the numbers in front to make it balance out like that. Okay, so let's backtrack here and get our notes straight. We're going to write down what I said. This is a lie. If you start with 2 oxygen atoms, then how can you only end with 1? And I think it's a good idea when you're taking notes for a new topic like this, it's a good idea to write down your thoughts. That way when you go back to read your notes later, you can tell what you were thinking. So if you start with 2 oxygen atoms, how can you only end with 1? Not okay. Okay. Solution. Okay, and this is the big takeaway from balancing. You need to pick coefficients, and that's a new vocab word here, coefficients. Those are the big numbers that I wrote in front of each reagent. And you need to pick them so that you have the same number of everything, start and end. So more specifically, you have the same number of every element in the reactants as the products. We, of course, will do several examples to make this fully sensical. You may get tested in whatever class you're in about why this is. The reason we need to do this is called the law of conservation of mass. Right? You cannot create matter in a chemical reaction. You cannot destroy matter in a chemical reaction. Those of you who have taken some fun physics classes or watched YouTube videos about the atom bomb, you may know that it is possible to convert mass to energy and vice versa. But this is just a chemical reaction. These are not atom bombs. The law of conservation of mass applies for us. Okay, so here's how to do it. How to. You start with an equation that is not balanced, like the one we just did. I'm going to do that again. And I'm leaving space in front of each one because in front of each item in this equation, we may need to put a number, a coefficient. Okay? So what you do is you count, you make a list of everything that you have in the reactants, and you should have those exact same elements in the products. If the elements are different, then you did something wrong. And then we just do a quick count. Okay, we're going to start with how many magnesiums are there in the reactants here. There are 1, and in the products we still have 1, so that's good to go. It's a good idea to do one element at a time, right? I did the magnesium in the reactants, then I went straight to the magnesium in the products. Now that I'm happy with magnesium, I'm going to switch and check oxygen. In the reactants, I have 2 oxygens because of that subscript, but in the products, I only have 1. Okay? So, we add a 2 in front of here. You can't put a subscript here, right? I can't just put a 2 there. No, no, no. That's not the formula for magnesium oxide. You can't change the formulas, okay? The only thing you can touch when you're balancing chemical equations is the coefficients, the big numbers in front of each item. Well, now that I've done that, I've got a 2. That 2 applies to this magnesium and it applies to that oxygen atom, okay, both. So now that changes my counts in the products. Now, the way I have it written, I have 2 magnesium atoms in the products and 2 oxygen atoms in the products. So now oxygen's balanced, check, but magnesium is not balanced anymore. Always go to the smaller side, right? I have 2 magnesium atoms in the products. I wish I had 2 magnesiums in the reactants. Well, I can have 2 magnesiums in the reactants if I just throw a coefficient of 2 in front. Now I have 2 magnesium atoms in the reactants, and now both magnesium and oxygen are balanced. The number of every element is the same in the reactants as the products now that I've fixed it. I have balanced the equation. Okay, so here's our final answer, and we're happy with that. Now, that doesn't seem so hard, I hope. Okay, that's not the type of equation that makes grown people cry. The type of equation that makes grown people cry is a little more complicated than that. So let's take a look at a slightly more complicated example. In particular, combustion equations tend to give people a lot of trouble. So here is me burning propane. So when you go get a propane tank for your gas grill, this is the chemical equation for that, and we know that combustion always creates CO2 and water vapor. And we got to check if this is balanced. You know, does it follow the law of conservation of mass? So I draw this dotted line here. That's the dividing line between the 2 sides of the equation. I'm going to make a list of all my elements again. This time I have some carbon, I have some hydrogen, and I have some oxygen. On the product side, I have the same 3 elements, and it's a good idea to write them in the same order so that it's easy to compare side by side. Carbons in the reactants, 3. Carbons in the products, 1. Uh-oh, not balanced. Pick the smaller side. I'm going to multiply this 1 by 3, and now I have 3 carbons. That's what I wanted. Good, now I have 3 on both sides. Hydrogen. 8. Product hydrogen, only 2. Uh-oh. So what number times 2 is going to give me the 8 that I wish I had? Obviously 4 times 2 equals 8. Now I have 8 hydrogens in the products, and now hydrogen is balanced. Finally, oxygen. Oops, I screwed something up here. The formula for oxygen gas is O2. I apologize for that. So I have 2 oxygens in the reactants. The products, I'm going to write it all out here. I've got 3 times 2, okay, plus, over here I have 4 times 1. So you may be noticing those coefficients count for the whole compound. And if I work that out, I get 10. Okay. So not balanced again. I got 10 in the products, 2 in the reactants. You always want to look at the smaller side. That's going to help, and that's going to ask me the question, what times 2 will give me the 10 that I wish I had? And that's 5. Now I have 10 oxygens, and we're good. That one wasn't too bad either. I'm going to move a little bit faster on this next example so this video doesn't get too long, but I need to show you where things can get tricky sometimes. Okay, so this time I'm going to burn ethane, which is a different hydrocarbon compound. We're going to end up with a little different situation here. Okay, make my list. CHO, CHO. Carbons, 2. Carbons, only 1 in the products, so I need a 2 right here to fix that. Hydrogens, 6. Hydrogen in the products, only 2. Go to the smaller side. I know that 3 times 2 will give me the 6 hydrogens that I want. Oxygen, 2 in the reactants. In the products, okay, I've got 2 times 2 right here. 2 times 2. Plus, over here I have 3 times 1. 2 times 2 is 4. 3 times 1 is 3. 4 plus 3 is 7. Okay, this isn't balanced. I've got 2 in the reactants, 7 in the products. So the question is, go to the small side. What number times 2 will give me 7? And there's where I start scratching my head. 3 times 2 is 6. That's too small. 4 times 2 is 8. Well, that's too big. What am I going to do? All right, this is one of the common situations that you run into balancing where things just don't work out the way you want to. So one thing you can do is you can cheat momentarily. You're going to use your eraser, and you can write down a decimal, because 3.5 times 2, that'll give me 7. Or, okay, if it doesn't work out, double everything. I'm going to end up doing this anyway. What do I mean by double everything? I mean, take all the coefficients that I've written so far and multiply them all by 2. Okay, this one right here is a 1. 1s are always invisible in chemistry, so 1 times 2 is 2. I don't need this one yet, still working on that. I've got a 2 right here. I am going to multiply that by 2 and turn it into a 4. And then I've got a 3 in the final one. I'm going to double that, and that turns into a 6. Now, I have to recount everything. I got to start over when I do that. But watch, there's going to be some magic here. It's going to help. Carbons now, I have 2 times 2 is 4. Carbons in the products, I have 4 times 1. 4 times 1 is 4. Okay, that's balanced. Hydrogen, 2 times 6. That's going to give me 12. Hydrogen in the products, 6 times 2. That's also going to give me 12, so that's balanced. Check. Oxygen, let's get rid of all this garbage. I don't know the reactants yet. Well, I mean, if I want to count them right now, I can just say there are 2. But products, 4 times 2 plus 6 times 1. All of that total equals 8 plus 6. 8 plus 6 is 14. And now, when I try to figure this out, it's going to work. Okay, the question is, what number can I take times 2 to give me that 14? And there is an answer this time. That number is 7 times 2. So now I have 14 oxygens on both sides, and we're happy. Okay, that one took a little extra work, didn't it? Okay. There were a couple of things we did that are very, very useful just now. A couple things that really helped us. Okay. So, tips. And then I'll be done with this video. 1. If you can't make it work, right? If you, oops, didn't mean to write like that. Sorry. So we'll get this out of the way for now. If you can't make a coefficient work, right, like if it's going to end up being a decimal like I found out earlier, then you can just double everything. And that will save your life. Okay. 2. You may not have noticed it, but there is a specific reason why I did carbon and hydrogen first. Okay, and that's because carbon only appears once on each side. Okay, and hydrogen only appears once on each side. Those are going to be the easiest elements to balance first. Oxygen, on the other hand, appears once on the reactants, but in the products, it appears twice. I like to call that a split element. When an element shows up a different number of times on each side of the reactants and products, it's like the oxygen split into 2 different products. You should definitely do those elements last. If you try to do oxygen first on this, good luck. It's even possible to end up in an infinite loop of balancing where you never are able to solve it. And the reason is that you have to do those split elements last. And if you can remember that tip, boy, that will save you so many long nights and so many headaches. Okay? Do the split elements last. Often that's oxygen. And 3, I'm going to leave for a different video. There is kind of an advanced pro-level shortcut that you can take in a lot of balancing problems. But this one's getting a little long, so I'm going to throw that into the next video, and you can optionally watch that. It's something you don't need to do. You can balance equations with what I've just taught you, but there is a pro tip that I can teach you that will make it even faster. I hope this helped a lot.